Find the derivative of the function. In example 1, the function is h of t equals the natural log of t times the quantity t squared plus 3 cubed. So when we do this, you will want to set u equal to t times t squared plus 3 cubed. That way, when you find u prime over u for the derivative, you will already have t times t squared plus 3 cubed all under, what's the derivative of this going to be? There's a product rule, so it's the first times the derivative of the second, but then you'll have to use the chain rule there. That sounds like a lot of work. There's got to be an easier way to do this. And there is. If you remember your log properties, you see that here there's a log of t times another expression. What that means is that we don't have to set u equal to this business. What we can do instead is separate this out. H of t equals the natural log of t plus the natural log of t squared plus 3 cubed. And even better, we can move this cube to the front, thereby making this derivative much easier to find. With this information at hand, we can start finding the derivative. I just need to rewrite this function one more time, just like this. From here, we can take the derivative of the natural log of t, so h prime of t. That will give you 1 over t, which is very easy to compute. No chain rule, no product rule involved. In this next one, we will have 3 times the argument of the log will go into the denominator, so t squared plus 3. And the derivative of that will go into the numerator of this fraction. So the derivative of t squared plus 3 is just 2t. Again, no crazy chain rule, no product rule. The only thing we have to do is simplify this, and this is 1 over t plus 6t over t squared plus 3. This is a good derivative for example 1. With the techniques that were used in example 1 here, with being able to separate out the product into 2 different logs and pushing the power to the front, we will not be as lucky to use that over here for example 2. In example 2, we will need to use the chain rule in this case. So in this case, u will be the natural log of x. So when we find t prime of x, it will end up being u prime over u. But u in this case is the natural log of x. So I know that t prime of x will be natural log of x in the denominator, and then in the numerator, the derivative of the natural log of x. But we already know that the derivative of the natural log of x is 1 over x, and this is all still over the natural log of x. From there, to get rid of this fraction within a fraction, we want to multiply the top and the bottom by the least common denominator, which is x. And what that will do is that'll leave you with t prime x equaling 1 over x natural log x as the derivative for this example.